Good morning, friends. Let's continue our discussion about virtual threads. In the previous video, we learned about the limitation of current servers and how the latest law impacts the overall design of the throughput, latency, and the concurrency about the server that we build. In the previous video, we also learned that if, for example, if a server, if it takes to serve 50 milliseconds for one request, even though we keep the latency intact, but after that, we can still increase the throughput if we can serve multiple requests concurrently. So if we just don't change any latency here from the server side, but we can still actually run a lot of requests concurrently. In that case, the throughput would be increased tremendously. And that's what we learned in the previous video. That using the virtual threads, because virtual threads, we can create a lot number of virtual threads, irrespective of how many OS kernel threads that we have. The platform threads, in place of that, platform threads are always limited to the number of OS threads that we have, or the virtual cores that we have in our system. But that is only for the platform threads. For virtual threads, as you can create a lot of virtual threads, it's just like a very lightweight way of creating those threads using virtual threads, and which can be mounted and unmounted on the carrier threads or the platform threads. That's why we can actually increase the concurrency. As we have seen that in the concurrency part, if we can have one thread per request for each of the client requests, in that case, we can have a thread per request style, which will definitely increase the throughput, although the latency, by the time by which the server can serve the request, although that is constant, but still the throughput can be increased. Okay, so this is what we actually went through all these cases. We actually tried virtual threads, then we tried platform threads, and we found that the throughput for this virtual number of virtual threads has been tremendously better than the cache platform threads. And for the fishbowl threads, it was for fishbowl thread, we already saw that it was quite poor in terms of throughput, although the latency is almost same for all of them. Let's try to expand this concept of latest law and the limitations of current servers by understanding more on blocking, non-blocking, and asynchronous server. We'll go through the complete example of TCP client-server socket connection. So if we look at this very basic diagram, so we have got Java net.socket APIs in Java. So suppose we are creating a server. So whenever we create a server socket, when that object is created, so we have to actually it creates a socket object at the underlying. Then it will bind a port on which the server is listening, and then starts listening on that port whenever we call the accept method. And this accept method is blocking, which means that there is one thread from the server side which would be keep on listening on this port for any open connection from any of the clients. We can have multiple clients like this, where each of these clients can try to connect at the same port, and then there would be a separate stream of connection being created between the client and the server to a new port from the server side. And the one thread which was listening on that port, that will again keep on listening once this client socket connection is created between the client and server on a new port. Okay, so this is the design. And whenever a socket is created, whenever it calls the connect on this port, after that, as soon as it returns, in that case, the connection has already been made. At the low level, at the TCP side, both the client and server have got several buffers. For example, from the client side, there would be a send queue, receive queue, and delivered queue. Similarly, at the server side, the same three queues would be there. As soon as the connection is made by using the three-way handshake. Three-way handshake means that the client will send the connection request first, and the server will accept it if everything is good, and it will send an acknowledgement back. At this point, client knows that the server is ready, and then it will again send one acknowledgement back that now the connection can be made, and the whole socket connection has been made. And now, because of these three queues which are there, send queue, receive queue, and the delivered queue at both the sides, this is where the TCP protocol, the TCP IP protocol would be working at the underlying level to transfer the buffer of data between these two. For example, when the client is sending anything, it will fill the send queue first here at this at the network stack, and similarly, it will keep, the TCP will keep on like putting into the network wire, and then it will, from the server side, the receive queue would be keep on receiving, and then finally it would be marked as delivered when when the server client program, when the server program has been able to read that from the receive queue. So this is at the underlying level, and as soon as the session is created, as we have read, that the write and both from the both the sides, the client and server can talk to each other. They can write on the socket and they can read from the socket using the input stream and the output streams. And finally, whenever the client will call the close method, in that case it will be the end of file message which is set like -1, and then the server will stop the connection and will close the connection. But server would be still listening on the port that it has opened to for the other client requests. So let's look at this sample program that I've created. So this is the server socket that we have. We have got this main method, sorry, and our server socket is listening on this port 8080. And this is where we call this constructor on this port, and now it is bind. So if you go here, we are bound to a port 8080, and then we actually can start the listening. This is where we call the accept method, which will block, and then it will always be listening for whatever the client has been sending the connection request. And I'm putting this in while loop so that our thread will keep on listening on this thread, although this is blocking. But still, I mean, once the is handled by one socket, for one of the sockets, it will again go back and will again keep on listening. So this is the handle method where the worker, I mean, whatever the socket connection which has been created between one client to the server, this is where the handling would be done for that particular request. So here I just put at this is the client request where we are connected to, and then I can use this try with resources. As you can see with Java 9, we can use this socket directly, which would be closed once we move out of this try block. At this point, at finally block, this socket would be already automatically closed. We can just provide it like this. And then what we are doing is that we are also creating an input stream and output stream on that socket. So the socket we are talking about is that we got return from this accept method when a client has sent a request, connection request to this server socket. So this is exactly at the same state that we are talking about here, that we have got this client server session, and then we are able to send messages and read messages. Okay, so here, there's one naive way that how we can just copy the from the input stream to the output stream, that whatever we are receiving in this socket, we can simply transfer it out. So, but here there's one caveat is that the default buffer size is only 8192 bytes. Okay, so that's why, I mean, if we have got more than that, then we have to do some buffering logic. So what I have done is that, again, it's a very naive implementation. I'm using a single thread for handling everything. This is so basically it's actually a single threaded server, because the same thread which is listening on the port, which is that is also handling the socket as well. Okay, so here what I do is a very naive way that we have learned that whenever the end of file is done, I mean whenever the client sends a close request, close method call, in that case -1 is returned. So this is what I'm doing it. So whenever the data that we are going to read from the input stream from this socket, when it reaches -1, only then it's a limit, and then we have to exit out of this try block, which means that we are closing the connection. Until then, if you don't receive, we are going to read 1 byte at a time. Again, this is not very efficient, and we're not buffering anything. So it's a very naive and the simplest way that we can create this single-threaded and reading 1 byte at a time. What we're going to do is that we are just reading it, and then we are simply writing it after doing some small modification on the data, just to show that, I mean, the data that we are writing back to the client, that is somewhat transformed. It's not exactly the same. You can do whatever logic that you want. Okay, and then finally, once we move out of the try block, which means that we have run the EOF, which is -1 end of file. In that case, we disconnect from this client, from this socket, and then and there is no more connection. And then the same thread which has been handling it will again go back here. It will see that the server socket is not closed, and then it will again start listening on this. Just notice one thing is that this is a single thread server, which means that if whatever the time has been taken to handle this request, until that time, if any other client is trying to connect, that has to wait in the queue on the network stack, it can, because the server is currently busy in handling one of the client sockets. Only when it is done here, only then when it's done and returned back, only then it can again accept the second client. So it's very much like a serial thread server that we discussed before. So if we go here, if one client is connecting to this server and this server is taking 50 milliseconds to serve it, then if there are multiple client 2 and client 3 also connecting while the server was handling it within that 50 milliseconds, all this client's connection has to wait. Only once the one server is done, once the server is done with one of the clients, only then the second client would be served. So it will be actually resulting in like a serial execution of all those client requests, which is not, of course, not very like it's the worst way that how we can design a server. Also, we are actually reading one byte at a time. So definitely, this is just for a demonstration purpose. So never try to like do this. Always try to make. We will go through like a lot of examples where we were handling multiple client requests at the same time, and how we will see that how the throughput, latency, and concurrency can be improved when we are writing this type of servers. Okay, so this is just for the demo of the servers. Now let's have a like quick sneak peek about the socket client that I created. So here, this is my socket client. This is what I'm going to build here in this client side. We have just gone through the server, which is a single thread server. Now let's look at the client code. So here, again, I start with the main, and then what I'm doing is that I'm using args for the ports that I want to create, or the number of sockets I need to create. For example, if I create, like say 3, if I pass argument 0 as 3, which means that I'm going to try 3 times for the socket connection, which means that it will mimic. So if I pass argument 0 as 3, it means that there would be 3 clients trying to connect to the server at the same time. Okay, so this is what it means. So here I can, by using this argument to this program, I can control that how many clients I want to create to connect to the socket. So here, once I read this, I will create this sockets array first for the number of, and then we will simply like loop through all those like the sockets length of this array, that how many socket connection that we want to do, and as we simply call this socket constructor. When we call a socket constructor, this is the very good thing about Java API, is that as soon as this constructor is returned, and under the hood, it is already doing the 3-way handshake to the server, trying to connect to the port 8080, where we have already running our server. And as soon as this constructor returns, it has already created the connection. Now we can use this socket as a client socket object, and then we can send a request to the server, and so. So here, what we're doing is that we are doing like number of connections, and then we are actually having a small sleep, and then finally we disconnect our session. So this is all about our client by which we can control it. Now let's have a quick demo, and then we'll see that how the single thread works. So let's run this. So this is my Socket API demo server. I'm going to click run button, or we can also directly do it from run. So it would be listening on port 8080 as soon as it starts, and we'll see this message, and this accept method will be blocking until we create one client socket client connection. So we'll see it all in. Okay, so servers is listening on our port, and it's still keep on running. So let's try to like run socket client first. Socket client, as we have learned that it will take one argument, that how many clients it wants to connect to this port. So let's start with so I already created one configuration. So you can go to run and then edit configurations. So here you can see that I have got socket client 4, in which I am passing the argument as 4, which means that there would be 4 clients would be connecting the socket at the same time. And I have got 10,000, which I will be using later on when I will discuss more about the virtual threads and more in that. So if I run this socket client 4 right now, so it will try to connect 4 times. So we can see that. Just let me click run. So here I've just click on the run button. So I expect that. Now you can see that the socket client, there were 4 connections which were being made. And as we can see that there was a new port which was created as soon as the connection was being made. Let's look at the server code. So here also we can see that server was listening on this. It got this from this one of the sockets on this port, and then it created a new client port so that the socket could be connected on that new port. Similarly, it did for all the other 3. And after that, it is all done, and then it's again listening on this port. So this is how it is done, because as we mentioned that this is actually a single threaded server. So it means that it has to handle all these 4 clients at the same time. After that, one by one, and after that it went back again because it's not closed yet, and it again started listening on this port. So this is what we can exactly see in our. So every time it is going one by one, and the client also, as we have seen that it will be for one client connection, it would be waiting for 1 second. So this is what is like you can say just a basic demo. We can also use right now our server is again listening and our client is all done. But so we can also use a putty session. So a putty, you can download it, and it's like a very convenient way that how we use in our office work as well. If I just click on putty and then I create a client like this, single threaded this, and what I'm doing is that I'm going to do a connection on the local host where our server is running on port 8080, and my connection would be telnet type. So if I connect this open, so we can see that now we have got one more connection from this putty session. And whatever I will type here, say this is my first line, and I put enter. So this is what I get back from the server, because I'm doing some small transformation. Is that the uppercase letters are moved to the smaller case and vice versa. So we can just play around here. We can put whatever we want like this, and every time it will return back from the server. So unless we close this, till then it would be connected, and now we can see that it is done disconnected, and our server is back again listening on this on the new client request. So this is what a very basic demo of Socket API. In the next video, we will see that how we can enhance this server, how we can make it multi-threaded, because right now it's like it's not perfectly designed. It's only can serve one request at a time. The same thread is listening and listening here and also handling that socket connection. So it's a very poor design. And also we are reading one byte at a time. So this all improvements we will done, and then we will learn that how we can actually scale this, how we can increase the throughput by using virtual threads. So see you all in the next video.